All right, here we're looking at section 8.1. We're going to start our work with quadratic functions. So our learning targets for this section is first we're going to identify characteristics of quadratic functions, and then we're going to graph and use them in this form. This form is f of x equals ax squared. Now let's explain kind of what a quadratic is. So a quadratic function is nonlinear, right? We've dealt with lines a lot, but this one's not linear. That can be written, here's my standard form, right? And we've looked at this a lot in standard form. So it's y equals, or f of x equals ax squared plus bx plus c, when a is not 0, right? I have to have this x squared term. And we've been dealing with this whole, in chapter 7, we looked at factoring a lot of these kinds of equations. So we've seen them before. This is just called a quadratic. So when I graph it, it makes kind of a U shape, and this U shape is called a parabola. So in this lesson, right, we're starting with just ax squared. So we're just starting with this very beginning part. We're looking at where b is 0 and c is also 0. So we're just looking at where we have an a value. So here's my core concept, my first one. So when we're dealing with functions and graphing them, we always want to start with our parent function, and then we can do some transformations on those. So the parent function for my quadratic is f of x equals x squared. This is the most simple that I can be when we're talking a quadratic. So all other quadratics are transformations, right? We move them around from this graph. And this is kind of what it looks like. So you'll see that the lowest point, the point where it changes direction, is called the vertex. So you'll see in my parent function, my vertex is going to be at 0, 0. This also makes the axis or the line of symmetry. You'll see that if I was to fold my graph along this dark dotted line, my graph would lay over top of each other. So it's an axis of symmetry. Also goes through the vertex. We'll see also that as I go from left to right, like I'm reading, right? We've talked about slope when we were dealing with lines. Now we're just talking about behavior of my function. So here I see that my function is decreasing, then I hit my vertex, and then my function starts increasing. That's really what I'm kind of looking at in behavior of my functions. So let's first look at this graph. So using the graph, then we need to identify characteristics such as the vertex, the axis of symmetry, and the behavior as the graph. So we kind of talked about this on that last slide. So you'll see that my function is decreasing until I reach my vertex, where it then starts to increase, right? And this kind of just makes sense because here it's going down and then we go up. I see that vertex is at this point -1, -2. So I just use my coordinate plane. So then that also means my axis of symmetry is going to be the x value of my vertex. So that's where my x equals -1 comes into play as my axis of symmetry. So from this, from my graph, we can also figure out the domain. So now remember, domain is all of my possible x values of my function. So when we're dealing with a quadratic, my domain is going to be all real numbers because both of these arrows continue on in forever and ever. So my domain is all real numbers. The range of this function, right? Now range is my y value, so I see that it's going up. So my range is all real numbers greater than or equal to -2. And you'll see that that range value comes from the y value of my vertex. So that can also come into play and help as well. So I also see that when x is less than -1, so when my x is here, my function is decreasing. So when my x is greater than -1, my y increases. Is that all we can see from that? That's the big part that we can see from the graph. The big things you're going to have to absolutely find are the vertex and the axis of symmetry. The cool thing is you guys have already worked on finding the x-intercepts, which we'll get there. That's by factoring and then solving. So we've already done that. So you're already a step ahead. So now I want you to look at these and to find the characteristics. The biggest thing I want you to find from here is the vertex. So now here's our second learning target, right? We're going to be dealing with graphing. So I always want to graph my parent function first. So one thing I know is here's my parent function, right? f of x equals x squared. So you'll see that in blue here. That's my blue parent function. It's just my plain graph. So if I have an a value, right, that is greater than 1, so it's bigger than 1, my graph gets a little bit more steep. right? And that A value is a vertical stretch, remember. So I'm just kind of stretching it up, which means I'm just pulling and it gets taller and skinnier. So if my A value is between 0 and 1, so if it's a fraction, it's kind of a vertical shrink, right? So I'm kind of pushing down and it gets less steep, both of them. Okay, so now if my A is negative, if I have that negative sign in front of my x squared term, that means my graph is flipped over the x-axis. Okay, so here's the blue one again, is just this blue one, but it was a negative 1. So again, if it's negative 1 and it's greater than negative, like if the absolute value is greater than 1, so if it's, let's say, if I see a negative 3, if A is a negative 3, something like that, so I've got negative 3x squared, it's going to be more like this green one. It's going to be fairly steep. So again, if I have a fraction, it's going to be less steep on my curve. The biggest things to think about is when this A is less than 0. So I'm going to have a negative sign, and it's going to be opening downwards. The only thing that really changes here then is going to be the range of my values, right? The domain continues to be all real numbers, but my range is now, instead of greater than, it's going to be less than that value. So the range really changes when I have that negative sign. So now let's look at an example. So I need to graph g of x equals 2x squared and then compare it to my parent function, which is f of x equals x squared. So the first thing I want to do is I want to make a table of values. And again, I like to pick 0 and then a couple on each side of 0. And I plug those values in as my x, and then I get my g of x. So if I plug a negative 1 in for x, I get negative 1 times negative 1, which is a positive 1 times 2, which is 2. So if I plug in my negative 2 squared is 4 times 2 is 8. That's where I get these values from. I just select a couple x values that I want to deal with, and I find my g of x or my y values, and then I plot them. So you'll see here in this graph, the black graph is just my parent function, is if I don't have a number in front of my x squared. And this is always where I'm starting. So then once I have my points, now I can kind of plot them. So I see that I'd have 1, 2, 2, 8, negative 1, 2, and negative 2, 8. So then I plot those points and I draw my smooth curve. So now I can compare the two graphs. So I see that they have the same vertex, and they also have the same axis of symmetry. So the graph of my g of x, my blue one, is narrower than my parent function. And I knew that it was going to be narrower because this value is greater than 1. So I know that it is a vertical stretch by a factor of 2. So that's just how I can look at both graphs and kind of compare them with each other. So now let's look at this one here. It's similar to what we just looked at. The big things I notice is I have a negative sign, so that tells me it's going to flip the graph and it's going to open downward. I also see that my A value is a fraction, which means it's going to be wider than my original function. So again, I just make my table of values, I pick some x values. Now the reason we picked these values is because I'm dealing with a fraction, and I'm dealing with a fraction with a denominator of 3. So I picked x values that would simplify easily, that I can plot those points and not get fractions from later on. So there is a purpose in selecting the numbers we pick. So if I had a fraction of negative 1/4, I would pick multiples of 4 here in order to make my life a little bit simpler. So now that I've got my ordered pairs, I go ahead and plot them. Here again in black is my parent function, my f of x equals x squared. And then you'll see in blue my h of x equals a negative 1/3 x squared. So again, you'll see that negative makes it open downward. And you'll see that it's not as steep, so it's a little less steep or not as narrow as the parent function. So again, my graphs have the same vertex, and they have the same axis of symmetry. But this one opens down, so the range will be different. So instead of my range being greater than or equal to 0, it's going to be less than or equal to 0 because it's down below here, down below my x-axis. So these are the monitoring progress in your book. And I want you really to kind of look through these and see what you notice about these graphs. So the big thing is, what do you think the graph's going to look like before you even graph it? Try a couple. So now here's kind of our word problem, our real life problem. So the diagram at the left shows a cross section of a satellite dish where x and y are measured in meters. Find the width and depth of the dish, right? So depth and width. So I see that I've got my equation and I've got several points that I'm given. So I want to use the domain of the function to find the width of my dish, right? And I know that I can use the range to find the depth. So the leftmost point is at negative 2, 1, and the rightmost point is at 2, 1. So my domain, right, the possible x values are from negative 2 to positive 2, which is 4 meters, which I can just count the distance here and see that I get 4. So the lowest point on my graph is at 0, 0, and I see that the highest points are here at this negative 2, 1 and 2, 1. So my y values are 1 for both of those. So my depth here is going to be 1 meter. So my satellite dish is 4 meters wide and 1 meter deep. So what's cool about this is I didn't even really have to use this equation to find those points that I needed to look at. I just have to note that it's a fraction, so it's not a super steep graph, but I haven't done anything else. So my vertex is still at 0, 0, and I have my axis of symmetry along the y-axis. So now here's your last monitoring progress. Try them and see what you can come up with. The first thing that I would always do with a word problem like this is to draw a picture and then label what we know. So let's look back at our learning targets. So first we wanted to identify characteristics of quadratic functions. Now just the biggest thing to remember for that is a quadratic has an x squared term. If it doesn't have that x squared term, then it's not a quadratic. So then we were able to graph and use quadratic functions in this form, f of x equals ax squared. So we know that in a larger quadratic I can have a b and c term out here, but in this section we were only focused on my a x squared, where my b and c were 0. So now that I've kind of seen an introduction into quadratic functions and I can graph them and kind of compare my new graph to my parent function, now I want you to go ahead and work on your homework for 8.1.